Welcome to Unit 3. In this unit, we're going to be talking about server operating systems and software. Now, as you may already be familiar with, an operating system is a piece or set of software that allows us to actually interact with the hardware. Last unit, we talked about all the different aspects of server hardware, which really is just a specialized subsection of computer hardware. We still have processors, memory, hard drives and SSDs, motherboards, cases, and power supplies. But how do we actually leverage the contents of that particular computer, or in this case, a server? How do we use a server that has 56 cores and 512 gigabytes of memory? Well, that all comes down to the actual operating system, the software that provides that user interface, the interface between us and that hardware. While we're on the topic of server operating systems, I want you to consider a question. Now, typically, when we think about interacting with a computer system, we think about the keyboard, the monitor, the mouse, our primary ways of interacting with a computer. We use the keyboard and mouse for input. Our primary output is that screen. We have other input-output devices, such as webcams, speakers, headphones, projectors, etc. But our primary use and our primary interaction with computers happen through a keyboard, a mouse, and a monitor. However, in a server environment, very rarely do we see these peripherals attached to servers. We've seen pictures of 42U racks filled with servers, but without any monitors, keyboards, or mice attached. The question then becomes, well, how is it possible to have all of this computing power and use it without a keyboard, monitor, or mouse? Or to put the question another way, what good is a computer without a keyboard, a monitor, and a mouse? Keep that thought in the back of your mind as we talk through some of the aspects of server operating systems and software. So just like in the desktop world, there are several different versions of operating systems. On the desktop side, we have Windows operating systems. Windows 10 is our current. On the server side, we also have a Microsoft Windows product. However, it bears the name Microsoft Windows Server 2019. Also on the desktop side, we have various flavors of Linux, Ubuntu, Fedora, CentOS, Red Hat, etc. On the server side, we also have some of the same flavors of Linux. Some of them are exactly the same, and some of them have been specifically created for server environments specifically. CentOS, Red Hat, Ubuntu will still show up on our server side in the Linux category. On the desktop side, we also have Mac OS, and on the server side, for a time, there was a Mac OS X server. However, that is not a heavily used product today. So while there are similarities, there are some significant differences between the operating systems designed for desktop use and the operating systems designed for server use. As you can imagine, one of the primary differences between desktop operating systems and server operating systems is their ability to interface with the high level of components that we have in servers. For example, Windows 10 may only be able to address 16 to 64 CPUs, depending on the version that you get, and only up to 256 gigabytes of RAM. However, on the server side, Windows Server can address over 1,000 CPUs and use up to a terabyte of memory. Similarly, the Linux versions on the desktop side may not be designed to leverage the multiple threads and massive amounts of memory available on a server system. Another big piece that's different between the desktop operating systems and the server operating systems is the roles and features that are built into the operating system. For example, DHCP is a role that we can assign to a server. For those of you guys who are forgetting your networking, DHCP, or Dynamic Host Configuration Protocol, is the service that allows client computers to connect to a network and receive an automatically assigned IP address. In the server world, it's not uncommon for a server to take that role on and provide those IP addresses. And so the server operating systems will have that as an option, not necessarily a default, but as an option inside of their operating system, whether that be a Windows server, Red Hat, Ubuntu, or Mac OS X server. However, in the desktop world, we don't usually want a Windows 10 desktop to start handing out IP addresses on the network. And so a feature like DHCP will be removed from the desktop operating system and only included in the server versions of the operating system. And in fact, the number of roles and features that are available and built into the server operating systems is staggering. And it's a significant difference between server operating systems and desktop operating systems. One other major difference between server operating systems and desktop operating systems may be the lack of a graphical user interface. Now, depending on the server that we use or the server that we install, many of those services, those roles, those features are configured via the command line. And if a server is going to be set up to offer a service and doesn't require user interaction on a regular basis, oftentimes the graphical user interface will be excluded from that installation in order to minimize the amount of resources that the operating system itself uses to provide more resources for the services that are running on that computer. So quickly to summarize, differences between desktop operating systems and server operating systems. Roles, features, software sets that's built into the operating system on the server side that won't exist over on the desktop side. Hardware compatibility, or the ability to address larger amounts of memory, more cores, more sockets, will exist in the server OS while it won't in the desktop versions. And lastly, the graphical user interface may be disabled or excluded in the server installation, where on the desktop installation it is a requirement to have that graphical user interface. Now, while we're on the topic of server operating systems, it's important to note that there's a special class of operating systems called hypervisors. Now, you may have heard that term in a hardware class or in another operating system class, but let me refresh your memory just in case it's not a term you're familiar with. Remember that an operating system is our interface to hardware. And in order for that operating system, that specialized software, to provide that user interface to that hardware, there needs to be a layer of code that interacts between the hardware and the software so that the hardware resources can be utilized by that operating system. And we call that layer the supervisor. The supervisor is in charge of knowing what hardware resources are available and providing those to the higher levels of the operating system as needed. When we get to virtual machines, we like to use what's called a hypervisor. A hypervisor is essentially an emulated supervisor, or a supervisor that is designed to give resources to multiple operating systems at the same time. So typically, if you're running virtual machines on top of a Windows 10 computer, the hypervisor is a piece of software sitting at the Windows 10 level above the real supervisor, but providing hardware resources to those virtual machines as though they actually had real hardware. Now, because of this layer of abstraction that we have called that hypervisor, we can do some interesting things, especially if we strip out everything else in the operating system except that hypervisor. And this is that special class of operating systems that I was referring to. Essentially, we call them Type 1 or bare metal hypervisors. It's an operating system whose sole purpose is to provide a hypervisor to virtual machines. Examples of this would be VMware's ESXi or Microsoft's Hyper-V. Now, while both of these companies, VMware and Microsoft, do provide what we call Type 2 hypervisors, or hypervisors that run inside of another operating system, they also provide these lower level hypervisors, which are very low level, very resource limited versions of their operating systems, specifically to host other operating systems on top of them. Now, the existence of these hypervisors make for some interesting applications. For example, we can have a single hardware server that may have dozens of virtual machines living on it and residing as servers on that one physical machine. We can also much more easily move servers from one physical piece of hardware to another physical piece of hardware simply by transporting that virtual machine. And because all of the hardware is virtualized, the server itself doesn't actually care what the underlying hardware is as long as it has the resources that it's configured to use. Not only can we virtualize operating systems on a whole or a server on a whole, but we can also provide limited virtualization environments, such as desktop virtualization, where we have one computer with one operating system, but multiple users can log in remotely, simultaneously, and get a desktop experience that's tailored to them, but using all of the same resources of that individual computer, what we call virtual desktops. Another is virtual applications, where somebody can open an application on their computer, and while it looks like the application is running on their computer, it's actually running on the hardware of our server and running in a virtual instance on our server, but they're seeing all of the graphical components on their side. Virtualization is a huge piece to the server industry as a whole. If you've heard of things like Amazon AWS or Microsoft Azure, they base their entire infrastructure on this idea of virtual machines, or small subsets of their larger physical infrastructure. When you spin up an instance in AWS, you're not allocating physical hardware to your specific machine, but you're getting a piece of the physical hardware that's part of the larger machine at Amazon. This keeps costs considerably lower and allows for variable amounts of performance when needed on a system that might cost thousands of dollars to implement physically, but you can create it virtually for pennies an hour. We'll talk more about virtual servers and virtualizing servers in another unit, but let's return for a moment back to our topic of server operating systems. In the next video, we're going to talk through the roles, features, special software that's typically included in a server operating system. Realize that oftentimes we interface with that server through a remote desktop connection or across a network connection, which is one of the reasons why we don't typically find a keyboard, a mouse, or a monitor. But realize that as we go through the roles and features, you'll start to understand that the purpose of a server is dissimilar to a desktop in that it's not designed for a single user to interface with it and interact with it at a graphical level. So keep that question in your mind: what good is a computer without a keyboard, monitor, and mouse?